Hi all, I hope you're well. So this is mock 5, right? And so with mock 5, the we're doing mock 5. What you're seeing is mock 5 because we've done mock 1 to 4 in the classes. So if you go and look in the classes, you'll actually see mock 1 to 4. The last two classes were revision class we spent doing mock 1 to 4. At some point in the future, I will record mock 1 to 4, but let's work through mock 1 to 5. So, sorry, let's work through mock 5. So, the question here says, which of the following accurately describes a fixed budget? Fixed budget is a budget that doesn't change with activity. It's typically our first budget. So if we're doing a budget for, I don't know, whatever, 100 units, we do the sales, the purchases, whatever, we just do it for these 100 units and we have the information, right? We're not looking at any changes. There is no change in the volume. We just have the activity for it. So it's literally the single budget. So it's a budget that is not designed to change as the volume of activity um, changes. We're just keeping it. So even if we have a change in activity, we don't we leave this as it is. So that's what this is. So the answer here is A. All these talk about change and review, and none of that really happens with a fixed budget. Question 2. What I did here was to do a little bit of a graph. An Excel sheet to make it clearer. Activity levels at 200. Total income 200,000. Therefore, unit income 1,000, right? 200,000 divided by 200, giving you 1,000. Then you have fixed costs of 100,000, but you also have variable costs. So what does that mean? So therefore, and then variable costs of 80,000, meaning the unit cost of each of these items is the 80,000 divided by the 200,000, which gives you 400. So you have unit variable cost 400, unit income 1,000. Right. So anyway, we make 180 units. Therefore, if you're making 100, if you're dealing with 180 units, you're selling each at 1,000. So that's 180 times 1,000, right? And I suppose the unit cost of 400,000 is the 400 times the 180 units, which is what you see here, right? So you have 180,000 minus 80,000, giving you a contribution of 100,000. But you now have to deal with a fixed cost of 100,000. So when you take that off, you have 0, right? And that's why you have this break even here of 0. And now question 3, let's look at this. With sales, it's really important to highlight that any change, two causes of change are volume and price. Well, let's look at volume. Imagine you were selling something. If you look at my notes again, you will see this for £50 and the cost was 30 and you're making 30. If there's no change in price, I'm sure you will agree that if this is one item, if you sell two items, you're literally doubling your profit and that becomes 60. I mean, because this would be 100 and this would be 40, right? So you can analyze, or you need to analyze, volume change or any excess revenue in volume terms by simply looking at the profit, which means here, when we're asked the volume variance, so we're expecting, therefore, standard profit of 10,200 over 600 phones. So that means the profit expected on each phone would be 10,200 divided by 600, which is 17. So if I'm expecting a standard profit of £17 on each phone, we're expecting to sell 600 phones. What you seem to have here is a change in volume, where volume falls to 580 phones. So you have a 20 phone variance, adverse of course. So you're short by 20 phones. You didn't sell 20 phones. Question is why? And in terms of volume, we'd be multiplying that 20 by the 17. So you'd be having 20 times 17, which is equal to 340. And this is adverse. So technically it could be B or C. That's the point for now. Right, let's create some space over here. This is recorded, so even if I clean this, you can always go back and look at things. Now, in terms of pricing, we are focused on the price on each of these units. You are to sell each of these units at £150. That's the plan, 150. And you sell 580 phones. So technically, I can find how much you actually sold each phone for. I don't need to. because I have the total. I mean, it says, so let's just see, 150 times 580 takes us to 87, takes us to 87,000. So you should have brought in 87,000, but you brought in 85,200. So I already know that you actually sold each phone for less. I don't need to find it. I can find it by simply dividing 85,260 by 580, and I will find how much you actually sold each phone for. So again, because I have the totals, all I literally need to do is to compare these totals. 87,000 minus 85,260. 87,000 minus 85,260 is 1,740. 1,740. And that's adverse as well. So you have an adverse sales price variance and a volume variance of 340 adverse as well. Okay, great. So your answer here is C. Right, let's look at here with question 4. Um, it says here that this is your budget, 1,500. You only need this figure to know what these are if you weren't given these, but you're given this. That's the only reason why we have this budget. Otherwise, we don't need it in our assessment of things. What's the situation? Well, it says that you're making 1,350 kettles. So therefore, I can tell you straight away how many hours I need to make them. That should be 1,350 times 0.25, which comes out at 337.5. So you need 337 hours to make these kettles here, right? Now, what does that mean? And you're paying £16 an hour. So that's where we are. This is what you should be doing. But what actually happens is that you actually use 340 hours. So you use 340 hours, which is higher. That's adverse. So that's you use an extra 2.5 hours, right? So um, of course, what's the word? Multiplying that or assessing that, that's 2.5 hours more. That's adverse, of course, adverse. Times a 16 gives you £40. So I already can see that I have a £40 adverse here. But let's just calculate the rate. So you were meant to spend £16 an hour. I'll just get rid of this. You were meant to spend £16 an hour on these phones. You've spent on 340 phones, then you would have spent 16 times 340. That's what would have happened. 16 times 340. So that's what you should have spent on this. 16 times 340 takes us to 16 times 340 takes us to 5,440. Yes, but you have spent 5,100, so that's favorable. Right? That's favorable. You've spent less than you should have spent, and that takes you to 340. So that's how we get the 340 favorable. Okay, so the answer is D. Okay, let's move on to this one. There is literally no difference here. Variable efficiencies are linked to volume, right? So that's nice. That's pretty straight. So what are we doing here? What we're doing is we will I just need some space so we can see what's happening here. I'll just use this space. So I'll look at volume first, or efficiency. That doesn't really matter. I just have a preference for that for a strange reason. Key point here is we're focused on the actual number of pumps that we're making. We're focused on the 220 pumps. Never forget that. This is just a standard. It guides you to know what these are. And we're given these, right? So this is the standard cost of each pump. We're given this, so that's great. So for 220 pumps, therefore, I'm expecting you to use 220 times 1,000 hours, which is 220,000. So that's 220, 220 hours, 220,000 hours, right? So I need let's give myself some space here. You know what, actually, I can use this space up here, actually. I've done this question, so So 220,000 hours is what I need, right? 220,000 hours. And the question does say that you're paying £3 an hour. So that's what you should be, that's how things should work. Let's change the pen color to see what then happens. What happens? So this is what happens. You use, oh, sorry, if I misread that. It says that the standard cost of each pump includes the following variable overheads, 1,000 hours at £3. Right, sorry, forgive me, I misread that. You should be using 1,000 hours, forgive me, to make 200 pumps. So let's fix that very quickly. So if you're using 1,000 hours to do 2,000 pumps, so 200 pumps, therefore one pump, yes, because it's all about standards, isn't it? One pump requires 1,000 over 200, and that's 5 hours. So yeah, forgive me if this was totals. I thought this was per pump. The way this looked, like I thought this was per pump because it said each pump. But just looking at this, it's per pump. So you need 5 hours to make each pump. So if we're talking about 220 pumps, which is what this question is saying you made, well, you should be using 220 times 5. The point is I'm always trying to get the standard. It's the standards I need. 220 times 5. And that's 1,100. So you should have used 1,100 hours to make these 220 pumps. Well, the question here is how many hours did you use? It says you used 1,200. So you've used more than you should have by 100. So therefore, the variable overhead efficiency variance is 100 hours extra at the £3, of course, which is 300. So I'm looking for 300. So these are the ones that look like 300. 300 adverse. So it's either this or this for now. So at least we have the 300 adverse in sight. Let's look at costs. So £3, right? So yes, you do. You're just going to clean this out. Yes, you use 1,200 hours, not a problem, but you should spend £3 on each of these, right? £3 on each of these. So 3 times 1,200 is what you should use, and that takes us to 3,600. Now I can compare that with what you actually did, because what you actually did, I just peeked that. I noticed that you used 3,300. Actual expenditure on variable overheads was 3,300. You did 3,300, so it means technically I can find out how much you actually spent on the pumps by dividing the 3,300 by 1,200, and that would sit here. But I don't need to do that. I can do totals as well. So in 3,300, so you'll have a favorable variance because you actually spent less than you should have. This is what you should have spent by 300. So what I need now is a 300 favorable variance here because you spent less. So the answer here is A. The answer here is A. Let's look at question 6. So what we have here is us trying to understand what would make a favorable material usage variance. In effect, this question is asking, what are some of the things, this is the standard cost of making a unit, and you make, for example, 500, and you were meant to make 500. You were supposed to use 500 kilograms to make, I don't know, whatever, 1,000 items, but in the end you use 500 instead of 550. Yes, you use 500 instead of 550. So the question here is why? Which of these reasons here work? We can see here using cheaper material is unlikely. The idea here is it's the fact that you've used less than you should. So we're looking at answers that give us a strong tendency towards the use of less material. And the best answer really is B here, isn't it? It's B. Look at number 7, which has identified a favorable labor efficiency. So similar idea, but call this hours. Say these are hours, right? So lower morale would make things worse, cheaper lower quality would make things worse, and idle time would make things worse. And the argument here, because we have now studied learning curve, please watch our last course video to discuss learning curves and discussed how learning curves mean that you do things in shorter time. So the answer here would be A. The answer here would be A. Let's look at what's happening here. It says that if the budgeted profit is £12,000, what we're seeing here is that to go from um, the budget to the actual, there are two issues here. There's material and there's labor. So in terms of labor, it tells you that you have a rate variance of 400 adverse and an efficiency variance of 200 favorable. Remember that these two combine to form the actual labor variance, the labor cost variance. So the fact that these are subvariances, by the way, these two are subvariances. So let's deal with this first. So these are subvariances. So these subvariances will combine, of course, to give you a net situation of 200 adverse, doesn't it? 400 minus 200 is 200 adverse. That's A, 400 adverse. It's 400 adverse. Materials, on the other hand, is we have a material price variance of 500 adverse, and we have a material usage variance of 750 favorable. Now, what they've done here is just play a little trick to sort of get you to show your understanding, to show that you understand what's really happening. Because you see, this 750 is made up of two more variances, which is the mix of 900 and the 150. But we don't need them because together they make the 750. So either you ditch the 750 and use these both, or just use the 750. Why not? So we don't need this. The material cost variance is the relationship between the price variance and the usage variance. And as you can see here, this is 250. This is 250 favorable, isn't it? This is 250 favorable. So what do I have in effect? I have 12,000. I have a favorable variance of 250 in terms of materials, a net variance. So that means that we spent less than we should have. So that reduces our cost. It's a profit. Sorry, forgive me. Oops, sorry. It's a profit. So because it reduces our cost, it increases our profit, right? We saved 250 on costs, so in effect it increases our profits by 250. It says it's always important to read the question. This is about profit. So reducing our costs increases our profit by 250. But here I have an adverse variance of labor. So an increase in my labor costs increases my costs and thereby reduces my profits. So my actual profits, because remember this is all about going from the standard to the actual, my actual profits would be 12,000 plus 250 minus 200, which is 12,050, and your answer is C. Right, so let's look at what's going on here. So we have a situation where we're told that the actual raw materials used, you actually used 496 at a cost. So you spent 600,448 on these materials. There's a figure here. You know what? You don't need it, but I'm just going to find it. And that's £13. That's what you actually spent, actual spend. Now I'm just going to change my pen color. Now the question tells us clearly what you should have spent. You say it's because this is a material price variance. So you've spent more than you should have by 992. So in effect, if you spent 6,448, you should have spent, I'll just take off the 992, 6,448 minus 992, which is 5,456. You should have spent 5,456 on these 496 liters, right? So you should have spent something here. And the question here is, what is that? That's 5,456 divided by 496 divided by 496, which is 11 pounds, right? And so your answer there is C. Then let's quickly go on to question 10. In question 10, what we see here is that it says they use standard costing. So again, very similar to what we were dealing with. Um, how many direct labors? So we can just I like doing things in the graph because you can always see what's going on. So it says here that the actual direct labor cost for the month was 70,000. So it says here that this is favorable. So we spent, if I'm just looking first of all at the cost here, so that means that you were meant to have spent 80,000 on these in this scenario. You're meant to have spent 80,000 on these number of units. So I don't know what these number of units are, but if you think about it, what I'm saying here is that you were meant to have spent 80,000, but you've spent 70,000 on these. So you've spent. Let me just change my pen color. Um, oops, sorry. Here we. Oops, sorry. So here we are. So you've spent 70,000 overall, which gives you a £10,000 difference, right? And so you spent so you should have spent so you actually did you spent so basically this is 70,000, but in red it's 80. Now the question says the standard rate for direct labor. So I know I'll just change my pen color that whatever happened, this was my standard rate, £10. So, well, obviously, if I'm multiplying 10, it must have been 10 times 8. This must have been 8,000 hours, right? Because I mean, it tells me clearly this is your standard rate. I know this area in red is 80,000. I know this is 10. So if you should have spent £10 per hour, and in total, I now know that you should have spent overall on this work of 80,000. I know definitely that you should have been spending. You should have been working on you would have been working on 8,000 hours. That's kind of the key point here. You use this to get you to what the standard is. It says it's favorable, so it means that the cost itself is actually 80,000 because that's what makes it favorable. The fact that you spend 10,000 less. Now that I know what that is, that's what I should have spent over the number of hours. I know what the rate is per hour, and I can find the number of hours. And so the answer is 8,000. I think this is a good way to always do it. Um, yeah, because that's kind of the point. Okay. um, so 8,000 is the actual number of hours, right? Actual number of hours worked. Okay, great stuff. So, key point here with mix, I highlighted this a lot during the class, was that you are interested in the actual number. It's just the mix you're interested in. So, you see, what I always said to you was to do the actual job, 8 plus 10. You're making a kitchen. So, this is what you actually did. What you then need to do, I'll just change my pen color, is ask the question, well, what should you have done in terms of mix? Should. And then immediately write 18. So your question is, I need to split 18 in the standard mix. The mix is 6 to 12, which is 1 to 2, isn't it? So in effect, you're asking me to split 18 in a mix of 1 to 2, which actually is 18 as well. That's actually, I thought this was going to be something else. So that's what you should have done. Well, let me now change my pen color and go into the world of, let's use that. I haven't used that color in a while. And oh no, it's not the best, actually, the variance. So you should have done 6. You did 8. So this is 2 hours adverse. Yeah, that's the point. You should have done 6. You've done 8. Here you should have done 12. You did 10. So that's 2 hours favorable. The question here is what are the amounts? So here this is skilled. So that's 2 hours adverse, right? You should have done 6. So that's 2 times 25. That's 50. Yes, adverse. And here you have 2 hours favorable, and that's 2 times 12, and that's 24 favorable. So 50 adverse minus 24 favorable leaves us with 26 adverse. Right? This is the mix. The mix is purely on the constant, the change in in mix. based on the actual number of hours invested in doing this thing. And that's the point here with question 11, right? So just do that, find that difference, and you're there. Cool, great stuff. We're looking at weighted averages. So what we're saying here is that a paper is weighted. Oh, I mean, all this makes up 100%, by the way, just in case you were wondering. Yes, this is how the 100% is made up of. So the question here is, in a way, we can find what the average is because we're saying, listen, in this one you score 56%. So in this weighting, you had 56% in the real exam, but only 40% of the whole exam is dedicated, or only 40% of the course is scored for financial accounting. So we need to multiply 46% times, well, I suppose 56%. It really doesn't really matter. 35% times 69% and 25% times 42%, right? So let's do that very quickly. 0.4 times 0.56. Here you have 22.4%. And then you have 0.35 times 0.69. And here you have 24.15%. And then here you have 0.42 times 0.25. And here you have 10.5%. Add these all together. 0.2415 plus 0.224. And you have 0.57. So 57% in effect becomes your weighted average mark. So you're just taking their share, if you like, as you're going along. Right. Question 13. Sometimes I get emails from students regarding this. Use the formula given to you. Use the formula given to you. The reason why n can change is because it's really a statistical issue. It's to do with population sizes. The bigger the population, the closer we could go to n. But we observe that the smaller the population, the smaller the sample, n minus 1 works. So just look at what exactly you've been doing. So the first thing to do here is to find the mean. Find the mean. And then the mean, of course, is 19 plus 22 plus 16 over 3. Right? Let's find that. 19 plus 22 plus 16 divided by 3. And that's 19. Interesting. So you have a mean of 19. So what you should do is you have your x, you have your mu, you have your x minus mu. So you have 19 minus 19, this is 0. You have 22 minus 19, this is 3,000. And then you have 16 minus 19, this is minus 3,000. Right, so next thing I need to just do is just square them, x minus mu squared. Sorry, I didn't have enough space here. 3,000 times 3,000 is equal to, you in effect have 9 million and minus 9 million that you're adding together. I'm sorry, 9 million and 9 million that you're adding together, because the minus 3,000 times 3,000 minus 3 on itself is 9 million. So you have a total when you add it all together, which is what this is saying. Well, you have 0 here, of course, right? So you had 0, 9, 9. You have 0, 9 million, 9 million. Add that all together, you have 18 million. And so what you now have, when we can now plug into the formula, is what is the square root of 18 million over 18, what's the square root of 18 million over 18, 18 million declares 18 million over 3, right? So find the square root of 18 million over 3. That's what you need to do in your, so 18 over 3 million is 6 million. So you're basically in effect saying, what is the square root of 6 million? And you get 2449, 2449, whatever. Okay, great. So literally don't write 6, write 6 million. It's just that I don't have space to do that. And do exactly the same thing here. Our first task is to find the mean. Oh, it's given to us. Perfect. So again, we have x, we have the mean, we have x minus the mean, and we have x minus the mean squared. That's the task in front of us. So we have here 34.5, and we have 35, and we have 0.5. we have 34.9, we have 35, we have 0.1, we have 35, we have 35, we have 0, we have 35.1, we have 35, we have 0.1, we have 35.5, 35, and we have 0.5. So let's square that, 0.5 times 0.5, and that's 0.25, 0.1 times 0.1. Here we have 0.01, this is 0, 0.01, 0.25. Let's add all these together, 0.25 plus 0.01 plus 0 plus 0.01 plus 0.25, and you have 0.52. So you have 0.52 in the end. So what you now have is S is equal to the sum of 0.52 over n minus 1. There are 1, 2, 3, 4, 5. There are 5 items, so 5 minus 1, and that's what you have to do. So 0.52, what is the square root of 0.52 over 4? 0.52 divided by 4 is 0.13. So in effect, we are asking, what is the square root of 0.13? Do that, and you have 0.36. That takes you to C. Question 15. The coefficient of variation measures how far the standard deviation is as a percentage of the mean. Right? So it's a good way of really analyzing, because the standard deviation as a number on its own is not entirely helpful. The same way gross profit on its own is not entirely helpful. It must be in relation to something else. So they give you this scenario. They tell you that the coefficient of variation is 8, and 8 is equal to the standard deviation, which is 96, divided by the mean. So suppose if you have this the standard deviation of 96, and you have a coefficient, so that means that the is equal to 96 over 8. If I just cross multiply, right, and bring those out, the mean is equal to 96 over 8. 96 divided by 8 is 12. So your answer here is 12. Right, number 16. Now I've highlighted that to do this question, there are a number of things. Please, you need to watch the videos on this value at risk scenario. I think it's necessary to watch them, because now when I do them, I'm literally walking through the process, and I'll talk a little bit, but I'm trying to explain what's going on. But you still need to really please watch those videos. So here this question is saying a business is planning to invest 40,000 over a period of 25 days. So we're basically using our understanding of standard deviation to make decisions, or to understand scenarios, right? So what we're saying here is that the information I'm really working with here is here. I'm saying here, listen, it's likely that I'm going to have a mean of a mean gain of £1,000. So I could get, so my expected output is my mean is £1,000. That's the first point that I want to make. And we've been talking a lot about mean and standard deviation. Standard deviation is what are the possibilities. So standard deviation just simply means I get more than £1,000, which would be this direction, right? For example, or I could get less than £1,000. The question here is, can I measure that? So it says here that the daily standard deviation over this period, so it's telling you that it's possible that this £1,000 that you could have could go up or down by, on a daily rate, £400. That's the first thing to understand. Now, we're not looking for the standard deviation daily, we're looking at the standard deviation over 25 days. So there is a formula given to you where you multiply the daily rate times the square root of whatever number of days. Now, which is why you need to watch that video, because I talk about this. If you're given a daily rate, you just multiply that by, if they had said 60 days, you'd multiply it by the square root of 60. If they had said whatever, you would do that. So you can see somehow this is a nice one because you're in an exam. So the square root of 25 is 5. So it's saying, in effect, that over 25 days, the square root of 25 is 5. over 25 days, the deviation can be as much as £2,000. So what is this really saying in terms of understanding? This is saying that deviation could go to £2,000 in this direction, negative. From starting off with the gain, you could have a gain of 1,000, but that gain could fall by £2,000 in this direction, or it could go up by £2,000 in this direction. Now, if you look carefully, please, because you need to watch that video, I talk about this being the first standard deviation, right? And this one is really a Z score. This is -1. And this is really a Z score. You see me talking about O plus 1. Now, if I double this, if I said, oh, well, I mean, it falls by 2,000. So when I say it falls by 2,000, it goes to 0, and then this is the fall. The fall is £2,000. So it can fall. You can go from a £1,000 um, gain, because that's what the average is. You can fall. So if technically you could go to a loss, you could lose. You could go as far as losing. If it falls by 2,000, if you have £1,000 and you fall by 2,000, you're going to minus 1,000, right? So, and this 2,000 is the fall. I think I want to stress that. That's the important thing. Okay. And this fall is can be measured in these Z scores. So a fall of 2,000 is 1. Another fall of 2,000 is what the Z score of 2 is, or another upwards of 2,000 from where you started would be 2. And you can keep going. So you need to watch. You could have 3, and really it ends at 3, really. So you won't understand this if you haven't watched the videos, but you can still actually understand it. You can just sort of follow where I'm going. Now that we've agreed that we have a deviation of 2,000, the question is asking, what is the likelihood, or what is the probability, what is the percentage that you will make a loss? Now, for you to make a loss, what we're really saying here is that, well, to make a loss, you need to really just fall by £1,000, right? Because that will bring you to, because once you lose 1,000 gain, if you fall by £1,000, you're at 0. So anything, what the question is really asking is that anything on this end is a loss, right? That's the question is, what's the probability of being in this part of the curve, if you like, because this is 0. So you're starting at £1,000, which is at the mean, and then you could fall to £0. So this 0 is really halfway. Let me just clean this up a little. This 0 is really halfway. So let me just use the actual numbers now that you see where I'm going. If you fall by £2,000, you're at minus 1,000. Halfway is 0. The Z score for this is 1, right? And the Z score for 2 would be minus 3,000, right? Because you're falling by 2,000 every time. 2,000, 2,000. But of course, to make a loss, we're saying that you need to hit 0. And the probability of being in this area, of just making a loss, is what they're asking for. So to do this, you will be given a chart. You will be given a chart that looks like this. So you can see here, just to highlight this halfway house of 0. Again, if, like I said, if the mean, when I say 0, £0, let's get rid of this. If the Z score for the mean is 0, and the mean for minus 1,000, which is falling by £2,000, is 1, well, the mean for the halfway point must be 0.5, minus 0.5, right? And watching the video clears this. I'm just really halfway between 0 and minus £1,000. That's £0, because the mean is £1,000. So another clean way of looking at it would be to look at it like this. Don't stay with me. Would be to look at it like this. £1,000 minus £1,000, and you are here at £0. But the Z score here is 0. The Z score here is 1. So if this is literally halfway, the Z score here must be this, sorry, minus 1, minus 0.5, right? And it's exactly the same on this side of the scenario here. You have here, if you had gone up by 2000, you would be at 3000. The z-score here would be 1. And here, where if you had made, it doesn't really matter. That's the z-score, and you keep going up because it is a distance of 2,000 pounds, isn't it? That's the point. So you need to be able to write that down and sort of contextualize what's going on there. So what do I do? It's asking what's the probability that I'm going um, to make a loss, and that's what's happening here. That means that you make no gain at all. So I need to find the area under everything up to here, and that's why those z tables matter. So the z tables measure from here, the probability from here. I repeat, the z scores help you measure the probability from here coming all the way. So if you're starting here at 0 probability, you're increasing your probability until you get all the way here to 100. So I can find the probability up to here. I can do different things with this. So let's go and see what that looks like. So because I'm interested in the z-score of minus 0.5, this table, what it does is gives you z-scores here and gives you in the middle, inside here, probability. Probabilities are here. The percentage probability, starting from, of course, like I said, the negative minus 3 points. So probabilities are really small, just a measurement. So I'm looking for minus 0.5, right? And minus 0.5, which is the z-score, minus 0.5, literally minus 0.50. That's what this is. If you look up here, right? This is the second decimal, minus 5, minus 5. This is like minus 3.91, minus 3.92, right? Minus 3.93. But coming down here, I'm at minus 5. And that's here. And that's 0.3085. So that's 30.84%. So what this is measuring, what this is telling me here, at this point here, oops, sorry, you should be able to see, maybe you can't see me. Oh, let me just download this. Sorry, maybe you can't see me writing. You'd have seen my pen. Just do that there. Download. Oh, sorry, desktop. Okay, so I can write on that. Right, so just writing on this, you can see here, this is what I was talking about here, this, right, because this is minus 0.5. I'm starting all the way from here. So this is, I'm going all the way. And I just want to know, the question is asking me, tell me about this area over here, because this was 0.5 as a z-score, minus 0.5. And that's my mean. And it's 30.845 or whatever. And that takes us to the first one, 31%. So the chance of making a loss is what's happening here. If the question had asked you, what's the chance of making a gain, then you would still do exactly what I did, but you're interested in what's happening here. Because you see, everything after this is some kind of gain, if you like, right? So it'll be literally 100% minus 31%, which would have been 69%. The question can ask you anything. What's the chance of having more than 3,000 pounds? You're interested in just here. So if you can find, which is what that chart gives you, the information up to here, then you find the difference because everything under the curve is 100%, right? So I said it takes a bit of practice, but you get there. So the answer there was A. Let's look at this next question. It says that the investor is planning to invest 40,000 over a 25-day period. Again, it says to you that the expected likely outcome, the mean, is £1,000. It tells us the daily standard deviation is 400. You know the daily. We're interested in what's happening over 25 days. So you have to say 400 times the root of 25. It's a formula. 400 times 5 is 2,000. So I know again I will have deviations of £2,000. Right. So with £2,000. So, and again, this question is now asking me with an 85% probability So just like I was using the z-scores to find probability, I can use probability. I can go the other way to find what point the z-score would be. So here's the thing. My first z-score, when it's 1, right, will be plus 2,000, right? I've said this before, it's 2,000, taking me here to 3,000. The net z-score of 2 would be plus 2,000 again, taking me to 5,000 in terms of gain, right? So I need to, but I can find the probability and find out what z-score I'm in. I mean, a halfway z-score of 1.5 is 4,000, right? I can, because it's even, it travels evenly. I can find gain based on z-scores. So let's do that. 85%. Let's go and find 85%. Here it is. Where is 85% in my, at what point? 85%, there's 0.85. I need 0.85. 0.85. This is the closest to 0.85. Just right here. You can see this is 0.8489. This is 850. So this is the best. What is the z-score here? The z-score is 1.04, right? So I come all the way here and I come all the way here. So my z-score is 1.04. Well, now that I know my z-score, I simply come back here. And I know that, if this is this is what the mean is 1,000 here, between here and here is 2,000. So think of it like this: every z-score, like a z-score of 1 is worth 2,000 pounds. So, right, because when I go from z-score 1, the movement is 2,000 pounds. A z-score traveling of 1 is 2,000 pounds. So I already know I'm 1,000 up here. So a z-score of 1.04 technically then must be 1.04 times 2,000, which is 2,080. So I'm actually traveling 2,080, right? Because a z-score of 1 is equal to the actual deviation, so 2,080. So I was expecting a gain of 1. It says that it isn't, with an 85% probability, we're looking at a gain of, well, on top of this, a deviation, an upward deviation of 2,080 on the 1,000, which takes us to 1,000 plus 2,080, which is 3,080. So we're expecting a deviation of 3,080. So if the question is asking, what is the highest return? Well, if you're planning to invest 40,000, when you add that 85% probability given to us, then you will now have 43,080. So again, I have to recommend watch the video, because at least that video helps you understand what z-scores are about and how we get there, and makes this a little bit more understandable. But some of you might pick it up straight away. Finally, it says here that we're doing exactly the same thing. We have a short-term investment which is traded on the stock exchange. The investment will be sold in 4 weeks. Not a problem. It says that the most likely outcome is £2,000. So I'm going to do that again. So £2,000. That's my most likely income. It's sort of my mean, but it has a z-score of 0. So I'm looking for the deviations, right? It says that the weekly deviation will be £600. We're going to sell it in 4 weeks. So we operate in the period. So like I said, if it was daily, you'd multiply it by the number of days. If it's weekly, you multiply it by the number of weeks to find what the deviation would be over the 4-week period. You can see they've made this quite nice because the square root of 4 is 2. So you have deviations of 1,200. So we're saying that you can lose 1,200 in one standard deviation, and that's a z-score of 1. Or you could gain 1,200, minus 1, sorry, and that's, you could gain 1,200 on top of what this mean is, right? This is the mean, the starting point. So we add on the 1,200 or take off the 1,200 depending on where we're going, right? We're doubling. And so we have 1,200, and then to go from z-score of minus 1 to minus 2, you have another minus 1,200. That's what you're really doing as you're going. Now the question here is that what is the likelihood that C will make a gain? So it's asking what is the percentage. So we're now looking for percentages. So to find the percentage, we need the Z score because that's the relationship. What is the likelihood that C will make a gain of over 4,000? This is really important. A gain of over 4,000. So the likelihood that it'll make a gain of over 4,000, well, let's look at this carefully. If you're here at 2,000, right, I mean, you have one standard deviation, 2,000 plus 1,200, that's 3,200. So actually, let's draw this out neatly so you can really see what I'm doing. So let me focus only on that positive side now so you can clearly see it. And it's just maths, just to kind of, so here I am, Z score 0, 2,000 pounds. So when I go from 2,000 to 3,200, this is a Z score of 1. This is a jump of 1,200. If you think about it, when I go another 1,200, I'll be at Z score of 2. So my profit, when the question says when you make a gain of over 4,000, so the question here is a gain of over 4,000 takes me, I'm just trying to find, well, what is the Z score for when it's 4,000? Is although I am interested in what's happening here when I make a gain of over, but let me just know what is the Z score of this point. Well, if you have from here between 1 and 2, 1,200, the question is asking, well, what is 800? So 800 over 1,200 is the distance, so to speak. So 800 divided by 800 divided by 1,200 is 0.66. I mean, this is 0.66, right, of this to get from here to here. So this must be 1.66, right? Because every Z score is worth 1,200. So 800 would be 0.66. But when I say 800, I just mean here, just here, just this distance from here to here. That's 1.66, right? That's 1.66. Or I suppose you could say, Oyen, what is 2,000? Because you can say 4,000. You could say, Oyen, 4,000 minus 2,000 over 1,200 will give you 1.66. We're literally saying what is the distance from the mean to from the 2,000 to the 4,000? What is the Z score going from 0 to whatever it is? Right? And I know that if I can find this area, everything up to here, which is what my Z tables will find me. Then the question is saying, what is the likelihood that you'll make a gain of over 4,000? So it's asking, because the question is asking what's the chance of you having even higher gains? Remember, we're going up, aren't we? 3,000, 4,000, 5,000. So I look in my table here and I find out what the Z score is for 1.66. And when I look at 1.66, 1.66, I find that the probability of that, of everything up to that point, is 95.154. It's this thing here, 95.154. I mean, look, it starts adding from here. But I'm not interested in this. I'm interested in after this. It's saying the gain is over 4,000. So I'm interested in this area here. So if everything under the curve is 100%, and this that I've just shaded is 95.4, well, it must be the difference. 100% minus 95.4. And that rounds up closest to 5%. Which is why I was saying, it's not difficult. I think you just have to watch the videos and just you be comfortable with Z scores, and then when you're now comfortable with it a little, there's some exercises I put in that. Then you can come and look at this, and this will make a bit more sense. Okay, great stuff.